about DFT FFT computations using DIF algorithm, decimation in frequency algorithm. So in this algorithm, we have to use the divide and conquer approach. So if we have n point DFT, we have to divide it into n by 2 point sequence, and then if we have n by 2 point sequence, that should be converted into 2 number of n by 4 point sequence. Example, if let us consider n equal to 8. So if we have n equal to 8, so if we have n equal to 8, so today's class we are going to study about the DFT FFT computation using decimation in frequency algorithm. So in this algorithm, we are going to convert the n point sequence into n by 2 point sequence, and then n by 2 point sequence we are going to convert into 2 number of n by 4 point sequence. So here, example, when you consider n equal to 8, so in that case, 8 is converted into 2 number of 4 point sequence, and 4 is converted into 4 number of, that is 4 is converted into 2 number of 2 point sequence. Like that it is converted. So to start with our algorithm, now we have to consider x of k equal to summation n equal to 0 to n minus 1 x of n wn power kn. This wn power kn we call it as a twiddle factor. So first we will be dividing into 2 summation, first for n by 2 data point sequence, and the next last n by 2 point data point sequence. That means if you substitute n equal to 8 in this equation, it will be 0 to 3 and then 4 to 7. So it is divided into 2 half. 0 to 8, it is divided into 2 half. One is 0 to 3, another one is 4 to 7. Because when you substitute the capital n equal to 8 here, it will be 0 to 8 by 2 is 4 minus 1, 3. So n equal to 0 to 3. Here in this summation, n equal to 8 by 2 is 4 and n minus 1, 8 minus 1 is 7. So it is 4 to 7. So it is divided into 2 half. So one is summation n equal to 0 to n by 2 minus 1. The next one is summation n equal to n by 2 to n minus 1. So what we have to do, we have to make both the summation to be equal. So for that we are going to use an assumption called n equal to n plus n by 2. So you are going to use an assumption n equal to n plus n by 2. So in the next slide, we are going to, first summation is 0 to n by 2 minus 1. Second summation is n by 2 to n minus 1. The second summation only we are going to change now. So for that the assumption is n equal to n plus n by 2. So now here is n, the lower limit is n equal to n by 2. Upper limit is n minus 1. Now first we are going to take the lower limit n by 2. It is in the place of small n we are going to substitute n by 2 and equal to n plus n by 2. Now in this, when you bring this n by 2 to this left hand side, it becomes n equal to 0. Now what will happen? This n equal to n by 2, it becomes n equal to 0. Then the upper limit is n minus 1. So now we are using the assumption n plus n by 2. So n plus n by 2 equal to the upper limit n minus 1. So here we are going to bring this n by 2 to this right hand side. So when you simplify, you are getting n equal to n by 2 to n by 2 minus 1. Now the limits change from n equal to n by 2 to n minus 1 as 0 to n by 2 minus 1. That means we have made both the summations to be equal. So the first summation, it is equal to the second summation. We have made both the summation equal. Next is, when we use the assumption n equal to n plus n by 2, wherever you have n, in this place we have to substitute it. So that's why we have replaced it with n plus n by 2 in this place and here in this place also. Next we have to simplify the twiddle factor wn power k of n plus n by 2. So this one we can write it as wn power kn into wn n power kn by 2. So when you simplify this term wn power kn by 2, wn is nothing but e power minus j 2 pi by n into kn by 2. So when you simplify, we will be getting minus 1 whole power k. So wn by n power k wn power kn by 2, it is becomes the minus 1 whole power k. This wn power kn remains as such. Now in this equation we are going to substitute. So first one will be summation n equal to 0 to n by 2 minus 1 x of n wn power kn plus the next summation is summation 0 to n by 2 minus 1 x of n plus n by 2 wn power kn. So because we are split into 2, one is wn power kn into minus 1 whole power k. Now in this we have to take the common term outside. So which is the common term here? The summation n equal to 0 to n by 2 minus 1 is common here. So we have taken it outside into x of n plus minus 1 whole power k into x of n plus n by 2 into wn power k is common. Kn is common here. So we have taken it outside. Now let us make this as equation number 1. Now in this equation, we have to split into even number and odd number. For that, we have to consider for even values of k, we have to substitute k equal to 2k. For odd values of k, we have to substitute k equal to 2k plus 1. Now the equation 1 becomes for even values of x of k, wherever you have k, we have to replace with 2k. So in this place, minus 1 whole power k, we have replaced with 2k. In the place of x of k, we have replaced with 2k. And wn power here, it is kn. So in the place of k, we have replaced with 2k. So now in this equation, when you simplify and write, it is for when you substitute the k value even number 1, 2, 3 like that. This minus 1 whole power 2k when in the place of k when you substitute 0, 1, 2, 3 it becomes positive plus sign. So the equation is summation n equal to 0 to n by 2 minus 1 x of n plus x of n plus n by 2 wn power k n by 2 power k, and this we can write it as wn by 2 power kn. So this we can make it as equation number 2. This x of n plus x of n plus n by 2 we can assume it as g1 of n. So this can be further used in the next stage. Next, for odd values of k, we have to substitute k equal to 2k plus 1. So in the place of here, instead of k, we have to replace with 2k plus 1. So we have substituted 2k plus 1 wherever we have k, we have substituted the 2k plus 1 here. Then in the place of k, when you substitute the odd values 1, 2, 3 like that, it becomes negative sign. So the equation becomes summation n equal to 0 to n by 2 minus 1 x of n minus x of n plus n by 2 wn power kn wn by 2 power kn. So this is the equation we'll obtain for the equation 3. Now we have to consider this. We have to consider x of n minus x of n plus n by 2 as g1, g2 of n. Now we have g1 of n as x of n plus x of n plus n by 2 and g2 of n as x of n minus x of n plus n by 2, where n varies between 0, 1, etc. n by 2 minus 1. Now we can write the equation in a simplified form as x of 2k equal to summation n equal to 0 to n by 2 minus 1 g1 of n wn by 2 power kn. Let us mark it as equation number 4. Then x of 2k plus 1 as summation n equal to 0 to n by 2 minus 1 g2 of n wn by 2 power kn. Now, in this, we have to assume that x of 2k, this is equal to, this is in the form of a DFT of g1 of n as g1 of k. And the equation 5, it is in the form of x of 2k plus 1 equal to g2 of k, which is nothing but DFT of g2 of n. So this is the result of the first stage. The next stage is we have to decimate the n by 2 point sequence into n by 4 point sequence. That means when you substitute n equal to 8 here, so we have to decimate the 4 point sequence into 2 point sequence. Now we have to consider g1 of k as a base equation here. Because g1 of k is a n by 2 point sequence, we have to decimate into n by 4 point sequence. Now let us consider the g1 of k as equation is summation n equal to 0 to n by 2 minus 1 g1 of n wn power n by 2 power kn. So in this we have to split into two half. One is 0 to n by 4 minus 1. Another summation is n by 4 to n by 2 minus 1. Now for your understanding, let us substitute the capital N value as 8. So if you substitute the capital N value as 8 here, the summation is 0 to 1. And here it is 2 to it is 3. So 0 to 1 and 2 to 3. So it is divided into equal half. So now we have to make both the summation to be equal. So first summation is 0 to n by 4 minus 1. Second summation is n equal to n by 4 to n by 2 minus 1. So we have to make both the summation to be equal. So for that we have to make a summation that is assumptions that n equal to n plus n by 4. This is an assumptions we are going to make it here. So when you substitute n equal to n plus n by 4, so we have to consider the second limit only because the first limit is 0 to n by 4 minus 1. We are not going to change the first limit. We are going to change only the second limit n equal to n by 4 to n by 2 minus 1. This we are going to change. Now our assumption is substitute n equal to n plus n by 4. Now um, n plus n by 4 equal to the lower limit is n by 4. So when you bring it to this, when you bring this n by 4 to the right hand side or to the left hand side, n equal to 0. This is for the lower limit. For the upper limit, again n plus n by 4 equal to the upper limit is n by 2 minus 1. So when you bring this n by 4 to the right hand side and simplify, you will be getting n equal to n by 4 minus 1. Now the limits changed from 0 to n by 4 minus 1 and both the limits are equal now. After that, we have to take the common things outside in this equation. Now g1 of k is summation n equal to 0 to n by 4 minus 1 is common. We have taken it outside. Then g1 of n plus minus 1 whole power k g1 of n plus n by 4 and w n by 2 power k is outside. We have taken it as common. After that, we have to substitute the k value, even number and odd number. For even number, we have to substitute k equal to 2k. For odd number, we have to substitute k equal to 2k plus 1. Now, in this equation, for even values of k, we have substitute k equal to 2k. Then the equation here becomes positive sign. So, this g1 of n plus g1 of n plus n by 2, we are considering it as d11 of n. So in the next slide, g1 of 2k plus 1, we have substituting the even odd values of k as 2k plus 1 here. So wherever you have k in these places, we have to substitute 2k plus 1. So when you substitute the k values from 1, 2, 3 like that, you will be getting a negative sign here. That is g1 of n minus g1 of n plus n by 4. So this will be equal to d12 of n. So similarly, we have to decimate the g2 of k into d21 of n and d22 of n. Now finally we have g1 of 2k as d11 of k, which is the DFT of d11 of n. g1 of 2k plus 1 is d12 of k, which is the DFT of d12 of n. g2 of 2k is d21 of k, which is the DFT of 21 of n. g2 of 2k plus 1 is d22 of k, which is the DFT of d22 of n. So now finally we have decimated that 4-point sequence into 2-point sequence. So thank